So we're milling off the top of the valve guides so I can drive them out with my valve guide punch. And all I'm going to do is mill the top down till it's flush with the body and then drive the valve guide out. So we're ready to install valve guides onto our cylinder heads, and the first thing I do is I go through and I measure my valve guide. The ones you see on the bench, these are all 13 millimeters. I just do the last 3 digits. These ones, what you'll see is 2 different sizes, and this is when the valve guide is machined. It's a 059, so it's 13.059, and at the top here it tapers up to 13.089. And I set these off to the side. This one's 090. I had one that was really high. It was at there it is, 0.101. So it went from 056 up to that line and 0.101. Now that doesn't mean that these are bad. It just means that I would need to refinish the valve guide to whatever my bore size is. So to do that, I'm just going to measure here. So this is 060, 066, 061, 062, 062, 070, so 063. So I'll measure it a couple of different times in different places. And sometimes all it takes is your micrometer being slightly off. So that's why I'm probably taking about 10 measurements. So 062. Can write on this one 062. So I've also gone through and measured my valve guide bores. Now I've honed the bores. I've already pressed in the new valve guides on these ones, but on this one I write the size beside the bore. So this was a 13.014. So what I would do is then go through my valve guides and match up the size on my valve guide to suit my interference fit into the bore. Now, if you have something that's bigger, these are a standard size. We can buy an oversize that's usually 0.25 of a millimeter bigger, and we can machine it down to whatever size we want. And in the worst case, I've actually machined my own valve guide when the hole has been outside of even an oversize. So each one of these you see has a size that corresponds to the bore, and then I just matched up each one, greased them up, and drove them in. So before I go ahead and ream the valve guides to my size, what I do is the driving in process with an interference fit kind of caves in this area of the valve guide. So I take my tapered ream and just a couple of quick twists. And all I'm doing is taking that little top section that is caved in with the driver bit and smoothing it out. I've still got to run my 9mm ream through each of the guides, and I'll set it up on my mill to do that to make sure we stay straight. And then I'll hone each guide to finish and suit each individual valve. So now I've got all my heads set up on our fixture here, and we're going to ream all of our valve guides. I have my ream installed, and I'm centered up on the valve right now. So the compressed air helps to keep the ream nice and cool, and it also helps to blow the chips out and down underneath our workface here. That keeps the ream cutting edge nice and clean and smooth. Okay, so I haven't honed these yet. I'm just dropping my exhaust valve in. Play feels good. These need to be a little on the loose side, and the big indicator is they pop. So as we pull it out, I just put my finger on the bottom of the guide, and that means the clearance between the stem and the valve guide is tight enough to where it will just create a suction and a vacuum, and we hear the valve pop. If you notice, when we did disassembly, it was one of the things I looked for, was to see if the valves popped when I pulled them apart, and these did not at all because they were just too worn out. Okay, so we're setting up our cutter, and we've just profiled around the first valve. So we've got a nice cut. We can see our seat in here. Nice good contact all the way around. And the other thing I want to check is on the back side of my valve. Now I already have my dial gauge set up at 46 millimeters, which is our valve protrusion, and we're allowed 0.3 or plus 0.3 after we've cut the valve. And right now we are sitting at, so our installed height is still negative 0.15 from 0.46. When we measured these, they were at around negative 0.03. So we're still ending up with our get it in, yeah, negative 0.16, negative 0.15. So still in the safe installed height range. Now I've got the cutter set up, I can go ahead and cut the other 5 seats. Okay, so I have reamed all of our intake guides, and I'm just setting up my cutter to do his cutter with our 3-way angle. And I've just done our first cut, and here's my intake valve that I've patterned. So we're right in the middle of the valve, nice clean pattern all the way around. So the next step now is just continue down the line, cut the rest of the 6, and then we're ready to go ahead and pull all this out of the fixture and start cleaning again. Okay, so I've cut all of my 3 angles, and there's one last thing that I do. I like to hand blend the last part of the seat, so I actually use one of my New Way cutters for that, and bring in a 3rd angle, a 4th angle actually, because I have a 3-angle valve job to begin with. I bring a 4th angle on both the exhaust and the intakes, throat those in so it's a nice even flow. The other things that I wanted to look at is I'm just going to put my valve in, and we're going to take our installed height measurement. So once again, I have my tool calibrated at 46 millimeters for installed height. I'm just going to slide that down, and we're sitting right at negative 0.23, so we're under that 46. The spec is 46 plus 0.3 is the maximum. I've already run down and checked them all. They're all within about 0.05 of each other. Then the last thing I want to do is just, while it's in the fixture, reconfirm my guide finish. And so I've run my ball hone over it one last time, and then I've just run down and look at each of the valve guides. Not sure how well you're going to see this. Yep. Make sure I want a nice smooth with a slight crosshatch to help hold oil, because once these are assembled with a valve stem seal, they're not going to get oil up in there. So these are all done, ready to come out and move on to the next phase of machining. On this one, we've got some wear on the cylinder head sealing surface right here. So the next step is into the lathe, and we'll remachine this surface, get rid of that wear that you see there. So when it goes back and they put it on the engine, they get a nice tight seal from the cylinder to cylinder head. Okay, so the last machine operation is one of the most important ones, because if you mess this up, then it can create all kinds of problems downstream with cam box leaks, cams freezing up in the cam box. The specified heights of the cylinder head have to be within plus minus 0.05 of a millimeter of each other. So what I do before I actually machine my cam boxes is I measure the before, and you'll see where I've written it right here. This one measured 84.495 millimeters. This one was 84.489, 0.486. What that allows me to do, this was my largest head. This one I took off 0.25 of a millimeter to clean it. So on the other ones, I'm able to get my finished size and get a little bit close. It didn't look like these had been machined before. This is a factory new size, which is 84.5. So what I then do is I write on my cylinder head how much I need to take off each head. Then once I machine it, I come back and remeasure my number. So this one landed at 84.220. This one landed at 84.214, and this one landed at 84.227. So right now we're holding a tolerance around 0.01, 0.02 between these three heads. This one had a slightly rougher finish than I like. There was something in the casting about halfway through the cut, and it balled up on my cutter. I since slowed down my cutting speed a little bit and changed my depth of cut, and the next one came out fine. This one's not going to pose any sealing issues. It just doesn't look as nice. It's nice and smooth. It'll seal up on the cylinder nice and fine. But occasionally, because these are a cast product, you'll run into stuff that's inside the casting. You don't know it's there until you start cutting. Okay, so I've finished machining all 6 cylinder heads. My tolerance, I ended up from subtracting my biggest number, or my smallest number from my biggest number. I ended up with plus or minus 0.014 of a millimeter. The heads before I started were at 0.025 of a millimeter, plus or minus. So well within the 0.05 that Porsche calls for. All we got left now is wash out, clean up, and begin our final assembly. We're putting new valves, new springs. We've got to set up the spring heights, and then these heads will be ready to go back to their owner. Okay, so the last thing that I'm doing here is just setting up my installed spring heights. These are 34.5 millimeters, which is this line right here. And I'm starting with 5 shims. Typically they can take anything from 3 to 6. Doesn't really matter too much as long as your installed heights are good, which we've already measured. And once I've got that, then I can install my new valve springs. This set of heads, the valve springs tested at below 20 psi. And so we're putting in a new set. You got to make sure when you install them that the closer coils are at the bottom. So now I got the height set. I can take the measuring tool out. Pull my valve. Going to lubricate my valve stem seal. Make sure that's seated all the way. And I'm just using an engine assembly lube on the valve stems. This is really the only place I use it, just because these do not get much lubrication at all. I want to make sure I work it in there. Coils closest. And the last thing I'm going to do is seat the collet and seat the valve. And that's it. Valves installed, spring height set, new valve stem seal on, everything's lubricated. We're just going to continue through, do the same to all the valves until we're completely finished with the heads, and then they should be ready to be returned. So the very last thing I'm doing is I'm marking the cylinder heads. How much was removed from the cylinder head as per the Porsche factory shop manual. So that way when somebody pulls it off, they can see it's minus 0.25.